introduction to RTU32, RTU32R, and RTU32S. In this presentation, we are going to give a summary of these devices and their features, making them suitable for power substations, SCADA and automation in sub-transmission and distribution levels. RTU32 and RTU32R are actually the same product, except that RTU32R comes in a 19-inch, rack-mountable, metal case. Thanks to its 500 MHz 32-bit processor, WinCE operating system, huge storage capacity, 1 millisecond timestamp, a collection of various communication ports and protocols, internal UPS, strong programming tool, remote programming, and redundancy, RTU32 is a versatile product that fits the tough requirements of sensitive projects in power grids, oil and gas, factories, and water distribution systems. Web-based graphic interface allows easy configuration. VGA and PS2 ports allow easy connection to keyboard and mouse, and display. You do not need expansion IOs for small projects with 28 IOs or less. For medium to large projects, you can add up to 1024 IOs. Use RTU32 with IEC 61850 protocol for substation automation, or utilize it with DNP3, DNP3WITS or IEC 101 for SCADA, or go with Profibus, Profinet, BACnet or CAN bus for factory automation. RTU32 and RTU32 can be used as gateways between different protocols, or as sequence of event loggers, or as data concentrators connecting several RTUs to a master station. Intelligent electronic devices, IEDS, such as smart meters and instruments may be readily connected to the RTU32 through Modbus or IEC 103. The hardware block diagram of RTU32 is shown in this page. As may be seen on the diagram, the heart of the device is an IPC CPU board which interfaces with the ISA bus converter for IOs through a PC104 standard bus. AC-DC power supply feeds internal circuitry. It has also a 12V DC output for external IO modules. Internal UPS is a built-in feature in RTU32. Besides, it has more than 256 megabytes of memory installed as standard. Similarly, the software structure in RTU32 is modular. The PLC runtime program and the web server work as real-time tasks in WinCE, the real-time operating system. The web server handles configuration parameters and settings including network TCP/IP settings, basic RTU32 configurations, PLC settings, time settings, SNMP configuration, and HMI pages. The Rhyton PLC runtime program, interface to the OS through a virtual machine, is in charge of the fast scan function, while it is linked to the various protocol drivers and other drivers. The Rhyton programming tool fully supports IEC 61131 and is used for making PLC programs in the RTU32. It supports programming languages such as structured text, function block, ladder, instruction list and sequential function chart. The PLC runtime supports cold restart, hot restart, and online changes. It supports several tools for multi-program handling and documentation. It is also a powerful tool for complete system design and programming, providing unique functions for event-based communication. The Rhyton workbench is used for protocols configuration, programming and debugging. Programming, debugging and upload and download of application programs can be done remotely via Ethernet or RS-232. I/O drivers for both internal and external IOs are connected to the I/O database, which in turn connects to the PLC runtime. Simple Network Management Protocol, or  agent is an independent task on the WinCE. RTU32 and RTU32 are design supports, single contingency withstand. The RTUs are designed for providing redundancy in the actual application. That means one point of failure will not interrupt the system functions. Obviously, the fault status will be reported. Redundancy configuration made simple. The software tools are designed for simple configuration of a redundancy setup. Default timing settings to be used directly for simple applications, no need for advanced timing adjustments. Advanced and flexible redundancy configuration programming supported. The RTU32/RTU32S series do also support functions available for handling more complex and advanced redundancy configuration with multiple drivers, advanced local control functions, etc. You can design your own redundancy application as you have access to both a wide range of status monitoring and to control functions in the PLC programming. Redundancy at no extra cost. Redundancy function is standard in all RTU32 or RTU32S series products. Therefore, there is no extra cost for redundancy. Basic configurations. Redundancy may be implemented in several ways, one of them being single RTU with redundant communication network. In this configuration, we have redundancy in network only. All communication protocols may be redundant. For time-critical applications, the same structure is applicable using straight and fast event binding protocol. With an impressive track record, this configuration is used for large applications like airports and power distribution automation. Configuration of this structure is simple and quick. It supports considerable fast and secure distribution of data between PLC runtime components. Status time tagging is obviously a standard feature. The redundancy function provided in the RTU32 support redundancy of processors as well as IOs. For example, you can have redundant RTUs with single IO set. In this combination, RTU8 is used as the first IO module, and functions as an intelligent IO controller. Otherwise, if you need complete redundancy, where both controllers and IOs are redundant, your system will look like this. In this combination, each RTU comes with full IO configuration, while all inputs and outputs are double-wired. The switchover time depends on the communication link, or links, between the redundant parts, and the failure detection time. Typical switch time for an RTU32 redundant application will be in the range of half a second, up to 3 seconds. Scan cycles and timing performance. The 4 parallel processes run independently, determine timing performance. These processes are ENIEC61131 application program cycle scan time, local bus cycle for expansion I/O modules, internal I/O bus cycle scan time, and WinCE general household cycle. The cycles run fully independent, or asynchronous, from each other. They do, however, have influence on each other as they all load the CPU time. In order to obtain the best possible overall performance, different priorities are assigned to the tasks. In general, processes for straight and application program and I/O handling run in high-priority threads in WinCE. The local bus driver is internally linked with a sub-processor, which manages the low-level local bus driver. It runs as fast as possible. The scan time depends directly on the number of connected local bus I/O expansion modules. Internal I/O bus manages the built-in I/O scanning. It provides fast I/O updates using an internal parallel communication. The Rhyton program cycle executes the application program developed in the Rhyton workbench. It is also runs in a high-priority thread. RTU32S is in fact a light version of RTU32 with a 200 MHz CPU, suitable for small applications. Except for the CPU speed, redundancy, and internal UPS, RTU32S supports more or less all features of RTU32, including the same range of supported protocols, same environmental ratings, storage memory, various ports, etc. The device is a perfect choice for RTU or controller applications in LV substations, water or wastewater systems, oil and gas pipelines, tunnel control systems, railroads, metro lines, airports, and factories. RTU32S also makes a perfect match for data logger and gateway applications. Ultimately, we are looking at a sample substation automation system using RTU32. As may be seen on the diagram, this is a simple network with RTU32, both as bay controller and RTU. The bay controllers are connected to smart meters and protection relays through downstream protocols such as Modbus or IEC103. They are also communicating on the upper network with each other and with a control room server, storage devices and HMI stations, as well as the substation RTU, which in turn exchanges data with the SCADA center. The bay controllers are also hardwired to the field devices through I/O modules. The upper LAN in this configuration may be simply IEC101, Ethernet with IEC104, or it may use IEC61850 protocol where specified for the substations. The RTU communicates to the SCADA center with DNP3, IEC101, or any protocol assigned by the SCADA master. Hoping this presentation was useful, we thank you for taking time and watching. Rhyton Global Marketing Team, 2015.